Alright, ladies and gentlemen, I'm still back with you. Before we solved first example, and the first example goes the way it was, and I believe you all get what it was. Now, we are back with another set of example which is somehow different with the previous one. And if you look at this very one, what we said here is just given the following arrangement of vectors, and the arrangement is this, and the angle is directly to the vertical line. So they said we should find the vectors along x and y axis. It's simple and straightforward, but there is one thing you need to consider. You need to always put your eye on. If I may ask, what angle am I going to use now? I was given 30 degrees to the vertical, but my own senses told me to use that angle to the horizontal. If you really want to get your component the way it's supposed to be. Now, in the solution part, we have our theta is 30 degree. That is to the vertical. What we are going to use, firstly, we have our component like this, which is f of y, and we have our component which is f of x here. So our f of y, always since it is false, this place should be false also. There is f sine of theta. Sine of theta, and the theta is to the horizontal. And the horizontal component is just f of x, which is f cos theta to the horizontal. But what we are given is just theta to the vertical. We have to get that to the horizontal, which is theta to the horizontal will be equals to 90 minus theta to the vertical, which gives you 90 minus 30. The answer is 60 degree. Therefore, our theta to be used in calculation here will be 60 degree. Now, what is our horizontal component here as x? The first along the x-axis will be f of x, which gives you r cos theta, and the r is the same thing as f, which we have the f to be 20 times cos 60. Now what we're gonna have is just 20 times cos 60 is 0.5. Now when you shift this point to the front, you cancel 1 0. Is that true? So what we're gonna have now is 2 times 5, which gives you just 10 Newton, and this is the force directly to the horizontal axis. So what we're gonna have is the other force to the vertical axis, which is f of y, which gives you f sine theta, and this f is giving us 20 times sine of 60. Now what we have is 20 times 0.8660. So the answer will be 0.8660 or 66. Generally we have 20 here. Remember, we have 0, we have 0, we have 0, we have 0, and we have 2 times 6 making 12. Put 2, carry 1. 2 times 6 is 12 plus 1, 13. Put 3, carry 1. 2 times 8 is 16 plus the 1 you carry, 17. You put them, you put 7, carry 1. Then 2 times 0 is 0 plus 1 is just 1. So what we're gonna have is 0, 2, 3, 7, and 1. So where we're going to put our unit, our point is just count the number of the small places after this point. We have 1, 2, 3. Count 1, 2, 3. The answer is 17.32. So the f of y will be 17.32 Newton. It should be better when you have your calculator close to you, but these are the actual forces that combine together to form this very force as 20 Newton. So that's how somebody can get this example. But the main idea behind this very example is you to know that you may be given an angle to the vertical. Whenever you are given an angle to the vertical, zero up your mind and make it to the horizontal. How? By subtracting that very angle from 90 degree. Whatever you get is what you are going to set on into your calculation. I am telling you and I'm advising you, this is how it is, and that's how you do it. You can still make use of this 30, but the sign attached to the horizontal, the ratios to the horizontal and the vertical component will change. If you decide to use 30, then this place will be cos instead of sine, and this place should be sine instead of cos. So that's how it is. But advisably, it's better for you to convert this angle to the vertical, make it to the horizontal, just like the way it is here. So theta h to the horizontal, which is 60 degrees, will be in use to make this necessary. So thank you very much. This is the second example. We are coming back to the third example. If you have any question, you can comment on our inbox. My name is always Ibrahim Kebrije, and I can never forget to you mine. Without you, I'm nobody. Thank you.